Hello everyone, welcome back to OR2, and on this video we'll start chapter 2, and the title of that chapter is the dynamic programming. So as it is indicated by its name, dynamic programming, the terminology dynamic means something that changes over time. So in the dynamic programming problem, we will find uh, a problem that we can divide it into stage, and the stage here uh, function like time but in a discrete way. So we know that time is something that is continuous, but most of the time in dynamic programming we will divide the problem into stage, and stage here in the dynamic programming problem is something that is discrete. So we will have stage 1 for the problem, we will have stage 2, stage 3, and so on till the last stage of the problem. In order to explain this stage, I will use this example. So here we have a road system, and we know the cost of following a road. For example, for going from A to B, the cost is 2, and for going from B to E, the cost is 7. And our objective is to find the cheapest route using dynamic programming. And it is very easy to see that this problem is the shortest route problem, and there is other algorithm that we can use to find the shortest route. But here you can see that we can also use dynamic programming to solve that problem. So the dynamic programming, it is a very powerful tool in mathematics that we can use to solve various types of problem. Okay, now I will coming back. I'm coming back to this stage. So in this problem, we need to determine what is the stage. So it is very easy to see the stage in this problem. So our first stage will be going from A to B or C or to D. That's stage 1. Our stage number 2, if you are at B, then we need to decide, will we go to E, to F, to or to G. Or if we are at C, then we need to go to E, F, and G. Or if we are at D, then we need to decide, will we go to E, F, and G. So that is our stage number 2. Our stage number 3 will be here. If we are at E, F, or G, then we need to decide, will we go to H or to I. Now our last stage, which is stage number 4, if we are at H or I, then we need to go to J. So this is our first stage, second stage, third stage, and stage number 4. So for this problem, we have stage, and the label for the stage is N, and we have stage 1, stage 2, stage 3, and stage number 4. Now, for every stage, we also have what we call as the state or the condition. So for every stage, the state will change. So in this problem, it is very easy to see that the state will be our position, right? So the label for the state is S, and since the state changes for every stage, then we will put it as S sub n. So S sub n or Sn means our state in stage n. Okay, so that is for the state. So for example, for n equal 1, so our S1 will be A, right? That's our position. So for n equal 2, our S2 will be what? That is our position for stage number 2. That will be B, C, and D. For n equal 3 or for stage number 3, what is our position? It will be E, F, and G. Now, the next thing that we need to know is the decision variable, what we call as the decision variable. Decision variable. Okay. And the label for the decision variable is x sub n. So that indicates our decision for stage n. Okay. So it is also very easy to see if we are at stage n, our decision will be what? Will be going to B, to C, or D. If we are at stage number 2, our decision will be, so we need to decide, will we go to E, F, or G? If we are at stage number 3, then we need to decide, will we go to H or to I? If we are at stage number 4, there is only one destination, and that's mean we need to go to J. So our decision variable, x sub n, that will be our destination on stage n. Okay. So since we want to find the cheapest route, so it is a minimization problem, right? So what we want to minimize, the total cost of going from A to J. So minimizing the total cost of going from A to J, it is the same as minimizing the cost of going for every stage. Okay, so let's label the cost as F, and remember we will have cost for every stage, and we're gonna put that as F sub n. So that means a cost function on stage n. And the cost will depend on what? It will depend on the state. So it depends on S sub n, and it will also depend on our decision variable or xn. Okay. Remember, if we are at A, then if we decide to go to B, then the cost is A. If we are at C, then the cost, if we want to decide to go to E, then the cost is 3. So the cost is a function of the position, and it is also the function of the destination. Okay. So what is the cost? It is just the cost of going from our position to our destination. Okay, and plus the cost of going to the next stage, right? So if our current stage is stage n, then the next stage is stage n plus 1, and we want to find the optimum cost for the next stage. So we put it Fn plus 1 star, and it is a function of what? It is a function of our decision in on stage n. So it is something like this. Okay, so that is our cost function. And what is this one? The Fn plus 1 star xn. It is just the minimum value. I mean, we have it here Fn plus 1 star, but in general we make it in a general formulation Fn star xn. That is just the minimum value of Fn Sn xn. Okay. So why it is the minimum value? Because our objective is to find the cheapest route. So as you can see from this function, so if we are at stage n, then we need to know the optimum cost up to stage n plus 1. So it is very easy to see that we will do the calculation backward. Okay, so because in order to decide our total cost for stage n, then we need to know the total cost up to the stage n plus 1. So that indicate that we're gonna do the calculation backward. So in dynamic programming, there are two types of doing the calculation. Number one, by doing it forward, and number two, by doing it backward. So in this lecture, we will do the backward method. Okay. Now let's start the calculation. So I think I need to copy the road system. Okay, this is it, the road system. Now remember, we will do it backward, so we start from n equal 4. So that is our last stage. So what is our cost function? Our cost function will be f4 s4 x4, right, plus c, which is the cost of following a road. So s4, our position, and x4, that is our destination for the stage number 4, and plus f star n equal 4, and here we need to have n star n plus 1, that is f5 of the x4. Okay, what I'm doing here, I am just following this function that we have before. But remember, we don't have stage number 4. We don't have n equal 4. And therefore, this is nothing, or it is just a 0. So for n equal 4, our cost function will be f4 s4 x4 equals c s4 x4. And what is our s4? S4 will be our position. So it will be H and I. And what is our X4? Our X4 will be J, because it is the only one. Okay. Now, let's do the calculation. Okay. We will do the calculation in table. Okay. So I'm gonna put here S4, and we will have here F4 S4 X4, and that equal C S4 X4. And then we need to find the minimum value of this function, and that means F star S4. So F star S4 meaning that the lowest cost if we are at the position S4. And what give that the lowest cost? What is the destination for that lowest cost? We label that as our optimum decision variable. So that is X4 star. Okay. Okay. So I'm just gonna put a line over here. So it will be in the table format. So S4 what is our x4? H and I. So that will be our position in stage number 4. H and I, right? There will be one destination, that is J, okay? So here I'm just gonna put x4. No, I will just put it over here. I'm gonna move it down, and our x4 here, x number 4 is this, just the J, that is the only one, right? Okay, if we are at H, then we want to go to J. What is the cost? The cost is 3. So we put 3 as the cost over here. So what is the lowest cost if we are at H? 3 is the only one. Of course, it is 3. So the lowest cost 3 is given by what? What is the destination for cost equal 3? The destination is J. Put J over here. Okay. And then if we are at I, if we want to go to J, what is the cost? The cost is 4. We put 4 over here. What is the lowest cost if we are at I? There is only one, 4, and that is 4 is the lowest one. And the lowest cost 4, it is given by what decision variable? The decision variable is J, that is the only one. So that is J also, right? So this is for n equal, this is for n equal 4. Okay. Now let's continue for n equal 3. Okay, we will continue for n equal 3 now. I will put it over here. Okay, so we will do for n equal 3, n equal 3. Okay, so what is our cost function for n equal 3? It will be f3. It depends on our position and our destination, and then the cost of going from a particular position to a particular destination, and plus our optimum solution for the n plus 1 stage. So since it is n equal 3 now, so n plus 1 is 4, and that depends on our decision variable for the stage for the stage number 3. So this is a function of x3. Okay, so here what is our s3? S3 is S3 consists of, this is stage number 3. So our position will be E, F, and G. E, F, and G. And our X3, that means our destination will be H and I. Okay. Now, we need to do the calculation again by using table. So I think I will make the size of the font smaller. So I will just put 18, I think. So we will have S3, and we will have the cost function, which is F3, S3, X3. It is just a cost of S3, X3 plus F star 4, X3. Okay. Okay, and then we need to find what is the minimum cost if we are at a particular position, and that is F star. Oh no, it is F3 star uh, S3, and then I think I need to move this a little bit, and then the lowest cost for that particular uh, position, we need to determine what is our destination. So that is x3 star. Okay, and remember our position will be E, and then F, and after that G, and we have two destination, which is H and uh, I. Okay, then I need this. Okay, I need to move this guy down a little bit. Okay, sorry, I need to move. Okay, so I need to draw a line over here so it will be clear. Okay, I will put a line over here so it will be clear also. Okay, now if we are at E and we want to go to H, E going to H, the cost is 1. Okay, cost is 1. But remember, what is the value of this guy? The optimum value, if we are on stage number 4 and we choose x3 as H, so we go over here, H, what is the optimum, what is the lowest cost? It is 3, so plus 3. And what is the total cost? 4. Okay, so it is like this. We go to, from E we go to H, and what is the, and that is the value of 1, so E to H, and that is 1, and the 3 is here. Okay, so the minimum cost if we start on H on stage number 4. Next, if we start at E and we want to go to I, from E to I, what is the cost? It is 4, right? 4 plus, if we are on stage number 4 and we start from I, what is the lowest cost? 4, right? So 4. So 4 plus 4, what that is? That is 8. Okay, so what is the minimum value between 4 and 8? That is 4. And this 4 is given by what? It is given by H. Okay, now we do the same thing for F, going from F to H. From F to H, the cost is 6. 6 plus, so we find H over here. What is the lowest cost? 3. So the total is 9. Here, going from F to I, 3. Right? I here is 4. 3 plus 4, that is 7. What is the lowest among 9 and 7? That is 7. And that 7 is given by what? By I. Okay. And then G going to H. What is the cost? 3. 3. H, if we move to the stage number 4, this is H. And what is the lowest cost for H? That is 3. So 3 plus 3, that is 6. 6. From G we go to I, the cost is 3. Okay, and if we are at I on stage number 4, what is the lowest cost? 4. 3 plus 4, and that is 7. And what is the lowest value between 7 and 6? And that is 6. And this value of 6 is given by H. Okay. Okay. So that's what we have for stage number 3. Now we continue to stage number 2. I think I need uh, the what the graph, the rod system. I think I'm gonna need it. Okay. Okay. Okay, I think I need to get rid of this guy. And now we're gonna start stage number 2. So for n equal 2, okay, so we will have f2 s2 x2 equal the cos of s2 x2 plus f star, oh, sorry, f star n plus 1, our n is 2, so 3 of x2. Okay. Okay. Now if we are at n equal 2, then what is our s2? Our s2 will be, let me see, b, c, and d, right? So b, c, and d, and our destination or x2 will be e, f, and g. E, f, and g. Okay, so this is it. Okay, now we need to make that table. So we will have what here? I think we will have here s2, and then we need this function. Okay, we need this function, and then our decision variable is e, f, and g. So we will have e, f, and g, and then our state will be b, c, b, c, and d, right? And then we need to find the lowest cost for stage number 2, f2 star s2, and what give that lowest cost, and it is x2 star. Okay. Okay. Okay, now if we go from B to E, the cost is 7. We go from B to E, the cost is 7, and plus I think I'm gonna need the table for stage uh, number 3, right? We'll just do here, copy, and then paste over here, so it will be easy for me to see everything. Okay, so if I go from B to E, the cost is 7. It is 7 here, plus, so from the previous stage, what is the lowest cost for E? That is 4, and that will be 11, right? So from B to F, the cost is 4. 4 plus F, the lowest cost is 7. 4 plus 7, that will be 11 also. From B to G, that is 6. 6 plus this is G, that is 6 also, and that will be 12. What is the lowest cost? It is 11. 11, and that 11 is given by E or F. So E or F. And we do the same thing from C to E. that is 3, 3, and here E is 4, so 3 plus 4, that is 7, and here will be from C to F, the distance, the cost is 2, and here F is 7 also, so 2 plus 7, that is 9. C to H, that is 4, 4 plus no, not from C to, it is from C to G, from C to G, C to G, that is 4, here G is 6, so 4 plus 6, that is 10. So what is the lowest cost? The lowest cost is 7, and 7 is given by E. Okay, okay. From D to E, the cost is 4. So here it is also 4. 4 plus 4, it is 8. So from D to F, let's see, D to F, it is 1. And F, it is 7 here. 7, 1 plus 7, that is 8. And from D to G, it is 5. And G here, it is 6. So 5 plus 6, that is 11. Okay, it is A over here. So A is given by what? By E or F. E or F also. So that is for stage number 2. And we think we need to continue to stage number 1. That is our last stage. Okay. I think I'm gonna need the road system. I'm gonna need it. The road system. Okay. I'm gonna need the road system. And then I'm gonna need the stage number 2. I'm gonna need it, I think, let me see where I can put that one. I can put that one over here, and I will put n equal 1 over here. For n equal 1, we'll make a border over here. For n equal 1, we have S1. And what is the S1? It is only 1, that is A. That is the A. What is our X1? B, C, and D. So we will have here B, C, and D. And here we have what? We're gonna have F star 1 S1. And here we have X1 star. Okay, and the function over here, it will be F1 S1 X1 C S1 comma X1 plus F star 2 X1. Okay, now going from A to B, the cost is 2. And from the next stage, for B, what is the lowest cost? Is that is 11. 2 plus 11, that is 13. 13. From A to C, the cost is 4. From stage number 2, so the lowest cost from C, that is 7. So 4 plus 7, that is 11. And then from A to D, the cost is 3. So from the next stage, the lowest cost for D is 8. So 3 plus 8, that is 11. So the lowest cost here, that is 11. 11 is given by C or D. Okay. We are almost done. Now we need to determine the the route. Okay, so here uh, we start from A, right? So A. So from A here, A we can go to C or D. So from A we can go to C or to D. Okay. So from C we can go to E. Okay. From C we can go to E. We got that from n equal 1. Right? From C we can go to E. And from D we can go to E or F. So from D we can go to E or to F. Okay, or to F. Sorry. Oops. Now, so we need to go to the next stage. From E, where is E? From E we can go to H. From E we can go to H. And from F we can go to I. Okay. F we can go to I. And the last thing, from I, sorry, from H, that's from H I can go to J, and from I can go to J. That's our final destination. Let me see. We have J over here, and we can go to J and to J. Okay, so the total cost is here 11. Okay, and this is the solution. So how many route that we have? We have 3 route: A C E H, or A D E H, or A D F. Sorry, the first route is A C E H I. Second route A D E H I, and the third route A D F I J. And the total cost of all is 11. They are all the same. I repeat, the first route is ACEHJ. The second route is ADEHJ. And the third route is ADFIJ. And the total cost of those 3 routes is 11. And I think that is it for the introduction to dynamic programming. And thank you very much.